1, in Introduction to Vectors. So when we talk about vectors, we talk about two things. We talk about first magnitude. So what this is a size, a quantity that is specified by one number. We also call it a scalar. So when you see scalar, just think of like a number. So age, like the scalar value for an age could be like 28. So like 28 years old. Volume, it could be like 30, which is like 30 milliliters, but like the scalar value would just be 30. Okay, speed, mass, temperature. So what are vectors? So a mathematical quantity that has both a magnitude and a direction. Okay, so it has to have these two things, 1 plus number 2, and then it is called a vector. So it needs a magnitude and a direction for a complete description. Example, weight, velocity, or friction. Okay, and we're going to get more into that. A vector can be represented by a directed line segment. Okay, basically directed, it just means an arrow. The directed line segment has a length, and the length again is called the magnitude, and then it has a direction, and the direction is going to be indicated by an arrowhead. So for example, if we say a plane is traveling at 500 kilometers an hour, so the 500 is a scalar, right? It's a value because it only describes the speed. Okay, so the 500 only describes the speed, but then as soon as we say a plane is traveling at 500 kilometers an hour northeast, now all of a sudden we have a vector. Okay, and that vector is velocity, since we have both speed and direction. So when we're talking about northeast, northeast points up this way between north and east, 45-degree angles between each. Okay, and AB may equal 500. Okay, and we're going to get more into this, but do you see how this is AB and then this is BA? So when we talk about AB, we talk about going from A. So this side is labeled A, and we're going to B. So in the same direction that we're reading it, the vector is going. So this one is called B to A because it's going from B to A. Okay, when we talk about magnitude, magnitude is always non-negative. So all the time you're going to see it maybe down here. It's going to be in absolute values, like AB, for example. Okay, we name each directed line segment by tail to head. Okay, such as AB or BA in that first example. Okay, when we talk about opposite vectors, what does this mean? In general, an opposite vector just means that it's going in the opposite direction. Okay, it's two vectors. They're going to have the same magnitude. So the magnitude of AB is going to be equal to the negative BA. Okay, this means that the vectors are parallel, but they're going in the opposite directions. Vectors can be represented with lowercase letters. So instead of going vector AB, which goes from A to B, we can also call it vector V. Okay? And then negative V would be, so instead of negative AB or BA, we can also call it negative V. Okay? They have the same magnitude, but they point in opposite directions, so they are opposites. We can name our vectors by using coordinate systems. So if we have a vector, vector A, so it's denoted by this, A, and then the vector symbol over top of it, vector A equals 3, 0. This means that A has its tail at the origin and its head at 3, 0. So 1, 2, 3. Okay. Usually on a coordinate system that would be a point, but this time it would be a vector. So what it's going to look like is it's going to have the tail on the origin, and then the arrow on that 3, 0. Okay, this vector has a magnitude of 3, of course, 3 units to the right. Okay, so absolute value. These absolute value symbols actually just mean magnitude. Okay, magnitude of A equals 3. So note negative A, like negative vector A equals negative 3, 0, and the magnitude of negative vector A equals 3. So the vectors A and negative A are opposites. We can say that vectors are equal or equivalent if they have the same direction and magnitude. Okay, that obviously makes sense if they're pretty much the same. Okay, this also means that the vectors are coincident. So this just means equal or equivalent. So AB or vector P is going to be coincident to vector Q, which is going to be coincident to vector R. Okay, so you can move them around, that's fine. They're all moving in the same direction, which is east, and they're all the same length. So if you take a ruler and you measure from here to here, they're all going to be the same length. Actually, I should put it at the tip. Okay, so all of these are equal or equivalent or coincident. Okay, so two vectors, let's just say A, B, and C, D are equal or equivalent if and only if. So this, if you take university math, you're going to see it written like this. This is not a typo. This just means if and only if. Um, A, B, and C, D are parallel to each other. And the direction from A to B is in the same direction from C to D. So parallel in same direction, pretty much those go together. Okay, if it's the same direction, they're going to be parallel. Okay, the magnitude of AB equals the magnitude of CD. Okay, the length. That's what it means by magnitude, just the length. Okay, example, again, these are not like absolute values. This is like the symbol for magnitude. Okay, so let's take a look at example 1. Rhombus ABCD is drawn and its two diagonals AC, so AC, and BD are also drawn as shown. Okay, just a reminder, ABCD, you have to go in order, ABCD, around the rhombus in order to name it. Okay, name vectors name vectors equal to each of the following. So what vector is equal to AB? So AB is here, okay? I get DC is also, so DC. Okay, those two are going to be equivalent or equal. They're the same length and they're the same direction. Okay, DA, well that's easy. We can do BC. Okay, same length or same magnitude, same direction. EB, which is going up, and we can say DE. DE. Okay, same magnitude, same direction. And then AE is going to the right, so we can say EC, which is also going to the right. Okay, and two more definitions right here. Geometric vectors. These are vectors that are considered without reference to coordinate axis. Okay, but algebraic vectors are vectors that are considered with reference to a coordinate axis. Usually, this is what's needed in applications. When we say coordinate axis, we just mean, say, for example, like the x and the y axis. And what we're looking at here is basically this number line that goes like 1, 2, 3, 4, 5, 6, and so on. And then 1, 2, 3, 4, 5, 6, and so on.